3. That means go.
That means go. Okay. Welcome everybody who could make it tonight for 6:30 p.m. Master Naturalist of Greater Baton Rouge Nature Notes. Tonight we're very delighted and honored to have Jay Grymes. If you don't know who he is, you don't watch TV, because he is the WAFB Chief Meteorologist. And we've seen him for years and years. Thank goodness he's been broadcasting wonderful weather news, and then I'm glued to the TV when we've got these hurricanes coming. So Jay joined Baton Rouge's WAFB TV as a part-time weathercaster in 1996 and became the chief meteorologist in May 2003. He joined LSU as a full-time research associate in 1986 and held a number of posts within the LSU system before joining WAFB, including a 12-year stint as a Louisiana State climatologist. Upon retirement, Jay held faculty appointments with LSU's Department of Geography and Anthropology and the Ag Center. He continues to hold an adjunct appointment with the LSU Ag Center as an extension specialist, assisting with research and weather-supported services for the Ag Center. He served as the co-editor and publisher of the Louisiana Monthly Climate Review for 17 years and has authored and co-authored numerous publications, including the ebook Louisiana Weather and Climate in 2002. He currently serves as the weather consultant for city, regional, and state agencies, and as a consultant for the Governor Office of Homeland Security and Emergency Preparedness, we know as GOSEP. And in 2009, he received the Outstanding Achievement Award in News Media from the National Hurricane Conference, and he's received numerous other awards. I have a very much lengthier introduction, which he gave me permission to shorten for the sake of time. But anyway, we are delighted tonight to have Jay Grymes. Thank you so much for coming to talk to us.
Well, it's absolutely my pleasure. You forgot to tell him that I was a former ambassador for a small Pacific island, but
oh, I did. I was at the bottom.
Right. We'll deal with that. I always hate to hear those bios because I never know how much of it is truth and how much of it is fiction. But it's a pleasure to be here, and you folks actually have more in common with me than you may realize. The gig and that's what I consider it, the TV gig, was an absolute accident. It wasn't anything I ever intended to do. It just evolved out of my work at LSU. And for those of you that might have some small interest, my undergraduate degree actually was in environmental biology, and I migrated to climatology because what I really got the handle on during my last years as an undergraduate was the importance of water in the environment. And so I moved to climatology because that was where I could link the influence of weather and climate to processes at the Earth's surface. So I was trained as an applied scientist, not a technical or a research-oriented scientist. And then came to LSU. LSU invited me down years ago to work on believe it or not, an agricultural insect problem. And that's how the entomologist brought me down. They'd seen some of the work I'd done at the University of Delaware, where I got my undergraduate and master's degree. And so I've had this great fortune of being able to work here in Louisiana. And by the way, my first winter here is when I determined I wasn't going home. So I love it down here, and I've been very happy to be here. And again, thank you for inviting me today. So we're going to talk a little bit about an array of little snippets here. I'm going to jump from topic to topic to topic, dealing with Louisiana weather and climate. And for those of you who do watch me, I know that many times at 10 o'clock you don't even make it to sports because I'll have you asleep in 3 minutes. So I'm a little concerned about whether I'm going to keep you awake for 45 minutes, but let's see how it goes. And if you do snooze during this, just please make sure to mute your mic. All right, so let's get right into it. Here we go then. So first off, and it amazes me in some ways how many people don't realize this, but we live in the wettest state in the lower 48. In fact, the Gulf Coast rim is the wettest zone in the lower 48. There are some places up along the Pacific coast that are wetter, but they're wetter in spots, basically, and the mountainside facing the Pacific Ocean, where you get that uplift as the moisture comes in off the ocean. But for all intents and purposes, we are in the hot spot. And yet, when we look at Louisiana, we have quite a range of rainfall variability. In the Florida parishes here, we've got some spots that average, and by average, I mean over 30 or 40 years, over 70 inches of rain. Basically 6 feet of water fall in parts of the Florida parishes on average each year. And less than 200 miles away off to our northwest, that number gets cut way down, under 50 inches, so about nearly 2 feet less. And so that creates quite a dynamic, both in terms of our natural landscape. It actually explains a bit of our agricultural variability. And whether you believe it or not, it even plays into our cultural differences. And it's not just about sort of the Anglo versus the Franco portions of Louisiana, but it's even things as odd as you might think as house types and community designs are different, because down here we've got to build around water, and in the northern part of the state, they have to be more focused about retaining water or saving water. So let's talk about that, because as I said at the very opening part, water really is what made me migrate from biology to weather and climate. And in fact, in Louisiana, no better example of the importance of water. Yeah, we're the wettest state in the nation, but that becomes a problem in terms of how we manage water and how we react to it. So we want to get a sense of how that water varies across the state. You just saw there's a big dynamic change in the rain amounts over the course of a year from southeast to northwest, but it's not distributed evenly through the course of the year. So when we look at locations comparing the southeastern part of the state, which are the grayer bars there, compared to the northwestern part of the state, the white bars, what you see is that, and I'll give you a second just to kind of get your head around this graphic. Basically, from October through about May or June, rainfall across the state averages about the same between the southeast and the northwest. But when we get into those summer months, that's where we see the dramatic change. In fact, during the summer months, we get about twice as much rain in South Louisiana as in North Louisiana. Now, a lot of people jump to the conclusion that that's a tropical signature, but it's not. What's happening there is, as we all know, in the summertime, somebody is going to get rain somewhere almost every single day. Well, over the course of those 3 months, that results in a period where we get a lot more rain, and these are showers and thunderstorms that drift off of the Gulf of Mexico and move inland. But what happens is, as they move inland, by the time they reach a line, basically somewhere up around Alexandria, they fizzle out. So we get those afternoon summer showers. The northern part of the state doesn't. And that creates a big difference, not only in the natural landscape, but also the agricultural landscape of the state. So here's 2 more, and these graphics are going to be some of the busier ones. So I put them in the beginning where you can still hang on and sort of pay attention, and then we'll get a little bit away from the dynamics of raw data here a little bit later in the talk. But what I want you to notice here, I've got 2 locations. One up near Shreveport, Red River Research Station, and the other right here in Baton Rouge, the LSU Ben-Hur Farm off of Nicholson. And what I've got here for you are the rainfall amounts, the moisture availability, that's in the blue, and then the potential evapotranspiration. Just think of that as the amount of water that would be used by the environment, both by the plants and by natural evaporation, if water was unlimited. And what you see here in these 3-month clusterings is that for the first 3 months of the year, we get more water than we need statewide. For the second 3 months of the year, basically spring, April, May, and June, rainfall and water demand are about the same. As we get into the end of the quarter, the last quarter of the year, October, November, December, we're back to a surplus period. And by surplus, I mean that the precip exceeds what the environment would like to get. So you see that through 3/4 of the year, water is not a limiting factor. But then when we look at those summer months, again, we see the dynamics of the difference between the water availability versus the water demand. And here you see that, again, up in the northwestern part of the state, which represents most of northern Louisiana, rainfall is below the potential evaporation, they're below the environmental demand. Whereas in South Louisiana, rainfall is still equivalent to the environmental demand on average. Now, that's obviously not true year in, year out, or season in, season out, but on average, we have a summer period where we get all the water we need in South Louisiana. They don't get it in North Louisiana. But the other thing to note here is that statewide, basically from fall through winter into at least early spring, everybody gets more water than the environment needs. And that also explains why that's also our flood season. A lot of people think, especially in South Louisiana, they think the hurricane season is flood season. Nope. Flood season is winter and spring, where on a year-by-year basis, we're almost always getting more rainfall than the environment is requiring. So you get a lot of runoff, and then the question is the timing of that runoff and how it affects local area rivers. All right, so let's look at a sort of a bigger picture, a longer window of precipitation and temperature across the state and get a sense of how our weather, or how our climate really, is variable. So here's a look at Louisiana statewide average rainfall. Now remember, we could break this down into north, south, and central, or any way you want, but what I've done is just simply clustered for the state as a whole. And one of the things you'll notice is that going back to 1895, basically the last 125 years, there has been a slight increase in the average year-to-year rainfall. You see it going upwards, an increase maybe close to 10%. Now, for those of you that have a little statistical savvy, a good question would be, is that upward slope significant? And the answer is yes, but just barely. So what I'm showing you here is that over the last 100+ years, it looks like Louisiana has, over the long term, maybe gotten a little bit wetter, but not dramatically so. But there's the first signal of climate change, and that really is a signal that becomes apparent even before we get into the whole climate change debate. So, and we may touch on that towards the end of the talk, depending on how the time goes. Now, one of the things I want you to notice is a very wet spell there from the 80s through the 90s into the late 90s. And that actually accounts for a fairly significant portion of that uptick in rainfall. Because if you look after that spell there, that about a 20-year window or so, you see that the numbers come down a little bit. So you always have to be a little careful about looking at linear trends, because they can be easily swayed by small blocks of years, especially near the beginning or the end of the time series that's out of the sort of the norm from the rest of the period. And what we have here actually is exactly that. If you look at the beginning of the series, over here in the first years, these numbers tend to be relatively low. These numbers here tend to be relatively high, and that creates a linear trend that really may not be the best way to express rainfall. Bottom line is, it does look like in the last 100 years, we may be getting a little bit wetter in Louisiana. If we look at it on a seasonal basis, looking at the summer there, you don't see much of a trend there in terms of rainfall, although in the last few years, there is maybe a hint of a series of wetter years here for the summer months. When we look at the winter, though, again, not much of an upward trend, but what I do want you to notice is the high degree of variability here. Year-to-year variability that really swings up and down. And that's where we get into trouble, because all it takes is a couple of these years, like in here, and suddenly you're dealing with significant flood threats because the winter months already are surplus months, and when they're exceptionally wet, our flood threat goes way, way up. All right, let's look at temperature, which is often the most frequently looked at index for climate change. And here we go. Starting in the 70s, you'll see that temperatures have just been on a steady rise in Louisiana. And that's not an artifact of the data. It's truly the case. And as I like to tell people, seeing that trend right there, the way it's going to get as warm as it used to be. And one of the things I want you to notice there is that with the temperature pattern for our state, we actually had a cool spell from the 40s into the 70s and 80s. And then we've rebounded to numbers that are very similar to what we had near and just after the turn of the century. You still have a lot of year-to-year variability in here, and you've got to keep that in mind. But the bottom line is we were warmer back in the 20s and the teens and even into the 30s, and then hit this cool spell before we've rebounded again into some local, and by local, I mean statewide warming. Now, this is a bit of a trend that we're seeing across much of the South. When we look at summertime average temperatures, you actually see a little bit of that. Relatively stable, yeah, variability here, but the average over this long stretch of years here is pretty stable. Then we have this little dip right in through here, and then our more recent rebound. So the summer temperatures seem to be following that trend. The winter temperatures also showing sort of a period of warmth in the teens, 20s, and 30s, a cooler spell here in the 50s, 60s, and 70s, and then warming again. Now, the obvious question is, Jay, what's going on? And unfortunately, the best answer is we still don't know. We really can't explain what caused that little dip here in the middle of the 20th century, but it's clearly evident in data, not only from an annual, but a seasonal basis as well. All right, so let's move on a little bit. Here's one of my favorite indices to follow, El Nino. And actually, we should refer to it as ENSO, El Nino Southern Oscillation. And you all hear about it. And in fact, especially in the 80s and 90s and early 2000s, every time it rained, El Nino got blamed for it. Now, El Nino is an important aspect to our climate, not so much a weather feature, but it is a climate feature. So let's take a look at it and just get your bearings here. Here's the Western United States, And during El Nino, what I'm showing you here are water temperature anomalies. And by anomalies, we mean, in other words, temperatures that are away from the norm. During El Ninos, the water temperatures in the central and especially the eastern Pacific tend to be warmer than normal right along the equator. During El Nino's evil sister, La Nina, the water temperatures along the equator tend to be cooler than normal. So you see these are sort of a flip-flop pattern of water temperatures, anomalies, if you will, along the equator in the Pacific. And the first question that comes to most people's minds is, what does the Pacific have to do with our weather? Well, let's just sort of keep in mind that on a global basis, the atmosphere tends to flow from west to east. So changes to our west translate into energy that gets sent downstream towards us and ultimately past us to the east. So these are, in fact, potentially big mechanisms for changing the climate signals over time for our location. Here's a better schematic for people to sort of get a sense of the dimensions. Here we are again. This is the warm sea surface temperatures, SSTs, warmer than normal water right along the equator from the central Pacific to the eastern Pacific. You see us up here in Louisiana and the Gulf of Mexico. And what typically happens in terms of changing the flow pattern, especially in the winter months, is that we tend to see this subtropical jet form. And that subtropical jet in the cool months flows near and close to the Gulf of Mexico. Why is that important? Well, it helps create more frequent lows over the Gulf of Mexico. So we're talking about more frequent storm systems, and these are Gulf lows. These are winter lows, not tropical lows. And they form down here, particularly in the northwestern Gulf of Mexico, and they can be at times fairly prolific rainmakers. And so not only does it make it wet for Louisiana during this El Nino phase, but it actually makes things kind of on the wet side for virtually the entire Gulf Coast region. So El Nino is a player in terms of our winter weather, and particularly our winter rainfall along the Gulf margin, essentially starting in as early as November and extending into and through the spring months. All right, here is La Nina with the cool water along the Pacific. Now, in this particular drawing, they haven't extended it all the way to the coast of South America, but you can think of it as extending all the way here. What happens here? Well, that subtropical jet becomes less frequent. It becomes less active. We see fewer winter storms again, forming in the Gulf of Mexico during the winter and spring, the cool months. And that tends to make us drier along the Gulf Coast rim. And in fact, if we look at the long-term pattern, bear with me, I'm trying to close one of these bars that has popped up for me. Okay. All right, so the long-term pattern here, where we have looking at sea surface temperatures in the Pacific averaged over a broad area, you see there this flip-flop pattern, warmer than normal, cooler, warmer, cooler, and back and forth and back and forth. And what scientists tend to do is we don't get too worked up about these small shifts. So we sort of take a statistical approach and just sort of take a paintbrush and paint through it. And so suddenly these smaller or less active warm spells here don't become an issue. But you see the big one here. There's the granddaddy, one of the granddaddy El Ninos, 82, 83, which, by the way, relates to the flood on the Amy of the 82 and 83, December 82 and April 83 floods that many of you remember. And then you see below on the bottom end of this spectrum, here are the big La Ninas. And many of these relate to very dry winters and springs. So you see that they're in this ENSO, El Nino, Southern Oscillation, El Nino, La Nina flip-flop pattern. It flip-flops not only over time in the short term, but also notice here we have a cluster of years where El Nino dominated. And then we get into a cluster of years where there's more of a domination by La Nina. So there's actually multiple cycles going on here. And the reason I show this to you is because now you kind of get a sense of just how convoluted trying to assess climate and weather and forecasting climate patterns can be when you really have to first try and determine how frequently are these events going to occur and how strong are they going to be. The stronger ones tend to have a more impactful signal. So looking at the pattern for El Nino, where you see the blue here, this is the region where we tend to be wetter than normal during El Nino years. And during La Nina, the flip side, you see just how well-defined that influence of drier weather is along the Gulf margin, depending on which of those two phases that we're in. Now, keep in mind, if this is a seesaw pattern, we have El Nino and then a neutral period as we swing from El Nino to La Nina and then swing back. Now, the swinging pattern is not evenly or even or cyclical, perfectly cyclical, as the previous slide showed you. And in fact, what we also find out is that, or what we look at, the way we look at it is, only about 25% of the years are El Nino years, 25% of the years are La Nina years, and the other 50% are the neutral phase, where we're sort of in between one phase and the other. This cycle occurs from one phase to the other, can occur as quickly as in a 2-year spell, but more typically takes 3, 4, upwards to 7 or 8 years to flip-flop from one phase into the other. So how does that affect our precipitation? If we look at rainfall during the first part of the year here, and we look at statewide average, remember now, during those cool months, rainfall across the state is fairly constant. Northwest Louisiana rainfall is about the same as Southeast Louisiana rainfall. But when we go into an El Nino phase, statewide, the state gets a little wetter. But when you look at the regional pattern, the regional influence for El Nino is not all that great in the northern part of the state. In fact, I basically, again, draw a line at Alexandria, and anything north of Alexandria, the El Nino influence is pretty limited. But the El Nino influence in South Louisiana is pretty dramatic. In fact, on average, rainfall nearly doubles during those first months of the year if we're in an El Nino pattern. And if the basically same rule applies with La Nina. In fact, La Nina shows a stronger relationship. Some El Nino years can be dry, most are wet. But when we look at La Nina years, almost all, 80% of the La Nina years are dry. Very few, if any, are actually wet. And by the way, right now we are in a modest La Nina. And although this month has been a little wet, the winter thus far is still drier than normal for much of South Louisiana. All right, flipping gears here. Let's get to a little look at some. So I'm assuming that we don't have any questions so far. So flipping gears now and talking a little bit about severe weather. And with severe weather, what I'm going to use, this is an easy graphic to interpret. It's a tornado history, the tornado climatology for Louisiana. And we'll use tornadoes as our sort of our highest level of representation of severe weather threats. And what clearly pops out in this slide is that spring peak, a primary spring peak that is centered around April and May. Now, as you move northward in the United States, the peak is also in the spring, but the spring peak is a little bit later. It's more of a May-June peak rather than an April-May peak. But what makes the Gulf Coast region in Louisiana unique is this secondary, oh, look at that misspelling, this secondary fall spike, which is pretty widespread for all of the Gulf states. But we don't see a secondary spike when you move north of our region. And what we're seeing here is the influence of cold fronts, just like the one we had today. And thankfully today's, the real energy stayed off to our east and northeast. We didn't get much in terms of way of active weather, but they've had a pretty active day in Mississippi, and they're going to have an active evening, I think, into Alabama and maybe even into Georgia as that front continues to push off to the east. So for our purposes, though, our real concern and our certainly obviously our main severe weather threat, we're right in the heart of it right now. It starts at the end of March and it runs through May into the first week or so of June. This is the time where we're most likely to get clobbered with strong storms, severe weather, and that potential for a really potentially catastrophic tornado. The other thing, and more commonly our problem down here, is lightning. And this is a map of lightning across the United States. And the first thing that should jump out at you is how active the southeastern quarter of the United States is. And in fact, we look down along the Gulf Coast and you see that there's a hot spot that extends from southeastern Louisiana into the Florida Panhandle. Now, the Florida Peninsula is certainly the lightning kingdom, if you will, because they get hit by storms from both sides. And what's prompting this is the storms that move inland off of the water, fueled by that daytime heating that gets the uplift going and kicks off those afternoon thunderstorms. And you can see with the Florida Peninsula, they get that potential on both coasts, both the Gulf Coast and the Atlantic coast. But here's an interesting fact. When we look at the lightning by counties, or in our case, parishes, check out, now these numbers change from year to year, but here's a 10-year run, and look at the 10 most active counties or parishes for lightning in the United States. EBR is number 4. That's pretty remarkable. And 6 of the 10 are actually in Louisiana. So there's a couple of reasons for that. And I do believe that East Baton Rouge has a elevated frequency for Louisiana compared to the other 6 parishes, largely because the city of Baton Rouge is a big lightning detection population center. We get hit a lot right here in the capital city with our tall buildings, storms that might not make contact on the ground as they move inland, and then they get into our populated area, and whammo, we get hit by the active storms. All right, changing gear one more time, and I think most of you probably remember this. Some of you may still have yet to recover from this, and it's still one of the most talked about aspects of recent Louisiana weather and climate, and that's August 2016. And you see the animation, about a 50-hour radar loop there, and you notice just how the system sits right on top of us. And if you look at that sort of orange banana-shaped pattern in there, it's just sort of a very, very rough outline of the Amite and Comite basins, which took the big hit with that system. One of the things that came out of that storm, and also Harvey along the Texas coast, Hurricane Harvey, is the apparent increase in big storms in the Gulf Coast region, particularly in the summer. And one of the issues was 2-day rainfall totals that were big storms like August 2016. So one of the things I did was I went back into the history book and I looked at all of the events in Louisiana where we received more than 20 inches of rain in a 2-day spell from 1930 up till 2020. And what's interesting to me is that there were only 6. And you see August 2016 of the 6, it's in there. Now, of those 6, 3 of them were tropical: August 1940, August 62, September 1998. The May 1995 flood that many of you may remember, that was the New Orleans flood. And then March 2016, that was the flood that, it was actually 2 distinct floods, one in southeastern Louisiana and another in northwestern Louisiana, and then the August 2016 event. Now, a couple of things to pick out there. So that over that roughly 90-year spell, there were only 6 events where there were 1 or more sites with 20 inches in 2 days. But the other thing to notice is that 2 of those events are in the same year, 2016, and that 2 of those events, 95 and March 2016, were not tropical. So a reminder that they don't have to be tropical events to be counted or to become monstrous rain events. Now, August 2016, was it or was it not tropical? Well, all I can tell you is it walked like a duck, it quacked like a duck, it just didn't get a name. And why didn't it get a name? Because we name tropical systems for the wind, not the rain. So August 2016 was clearly tropical in design, but we never got the wind, and so it never earned the categorization of being a tropical system. Now, one of the things I fret about a lot with that 2016 event is demonstrated right here. That system started in the Florida Bend region 5 days before it got here. And it slowly drifted westward for 5 days, with the heart of it staying out over the water the whole time. So notice as we go from the Florida Big Bend there, along the Florida Panhandle, there's one little bullseye there kind of southeast of Tallahassee, but there's really no big rains along the Panhandle. No big rains in coastal Alabama, or even really any big rains in coastal Mississippi. But when we looked at satellite data after the event, and here's the problem, after the event, the satellite data was suggesting rain rates or rain amounts of 20 to 30 inches of rain just offshore. So we did have some evidence that this was going to be a prolific rainmaker. But what we didn't know was that it was going to take that right turn at Albuquerque, as Bugs Bunny would say, and head inland over us and then sit still there for 2 days. And so, yes, we knew we had a potential rainmaker. We just didn't know it was going to do this and then sit here. And by the way, a lot of people in our area aren't aware of just how big of a mess it was for the Lafayette area. There were actually 2 floods in that event: the Baton Rouge metro area flood and the Lafayette metro area flood. And in fact, both of those events were of very similar dynamics in terms of both rain amounts and the size of the bullseyes. You'll notice 2 distinct bullseyes there, both produced by the same rain event. Both recording more than 24 inches, more than 2 feet of rain in a 2-day window. Now let's shift this map a little bit. And here's where we get caught up in some, what I think is sometimes misrepresenting the storm. So we've got these bullseyes here where it rained cats and dogs. And we come up with this number of a 1 in 1,000 chance of occurring. Now, the first question is, where does that come from? And how do we arrive at that number? Well, it's purely statistics, but we've got to kind of think about what is it really representing. So if we look again at these spots, by the way, there's the Amite Basin laid down underneath that rain. And you see, first of all, for the Baton Rouge area, it was kind of an east-west path of rain, where it was a little bit more circular in shape for the Lafayette area. But guess what? When we talk about how that event impacted us, so there's that rain event. What would have happened if we'd have just taken that rain event and moved it north 25 miles? Well, it would be a different storm, but it would have had the same impact on the basin. So regardless of whether this might be, let's say it is a 1 in 1,000 year rain event, it is not a 1 in 1,000 year flood event, because the same rain pattern just moved a little bit would have created the same effective flooding and it would have been a different storm. And in fact, the same would have been true over in Lafayette. Move that storm north 20, 25 miles, it still all collects in the Vermilion Basin, and the flood losses in the Lafayette area would have been virtually the same regardless. And my point here is that we have to be careful about how people want to leap to the conclusion that that rain event represents the flood event. Even if we want to say it was a 1,000 year flood event, which I don't think it was probably something more along the lines of a 1,000 year rain event. It was probably more along the lines of a 100 year or 200 year flood event. And when we talk about flooding, Louisiana is the hot state. Here are the top 10 events for National Flood Insurance Program payouts over the last 30 or 40 years. And notice that the top 10, Louisiana was involved in 6 of them. Just a reminder that this is a flood state. So one of the things I like to ask people is, should I consider flood insurance? And the short answer is, okay, it's a 2-question quiz here. You can take it home, give it to your friends. You don't even have to shout out loud. You just ask yourself these 2 basic questions. Do you live in South Louisiana? And the second question is, has it ever rained in your backyard? If you say yes to both of these questions, you really do need flood insurance because, and people say, but I've never flooded before. Well, of course not. Most people don't ever flood until that first event. We do have repetitive flood areas in South Louisiana. And in many cases, the real question is, what are folks still doing living there? All right, that's the end of the little commercial for flood insurance. So let's talk about what we think we know in terms of flooding. So we're the wettest state in the lower 48. Now, by the way, being wet is one of the reasons why it's sportsman's paradise. We've got water everywhere. It is a wonderful place to be for outdoor activities. And in our zone, Southeast Louisiana, we live in the wettest part of the wettest state in the lower 48. So, of course, outdoor activities and the environment love the water and expect the water. Indications are that rainfall may be getting even or continuing uphill. Rain amounts may continue to increase on average in the coming decades. The real question is, are we likely to see an increase in these mega flood events like we saw in August 2016? And the bottom line to that is we really don't know. What I need you to understand is, and need people to understand is, we got to quit calling that 2016 event the 1 in 1,000 year event. It wasn't that. We're basing that based on a statistical hocus pocus that's derived out of less than 100 years worth of data. And by the way, for that statistical application to work, we have to assume stationarity, that the climate hasn't changed. Well, I just showed you earlier in the presentation that the climate has been changing just in the last 100 years. How can we really extrapolate 80 years worth of data out to make such an audacious claim that the August 2016 was a 1 in 1,000 year event? In fact, statistics show us that even from the rainfall standpoint, it may have been something more along the lines of a 200 or 300 or 400 year event. Still incredibly rare, but not as rare as the 1 in 1,000 magic number makes it seem. All right, let's go off to another subject here. One of my favorites, and one that has certainly captured my attention my entire time. In fact, when I came to Louisiana in 1985, I got here in time for 3 named storms: Juan, Danny, and Elena, 1985. And it was quite an experience for me because I grew up in Delaware, and in 30 years, I only dealt with 1 tropical system. So to hit 3 in 1 year was quite an eye-opener. But before we get to talking about hurricanes, I want to make sure that we're all on the same page. So we need to make sure that we all have the basic understandings on what is a hurricane and where do they come from. And as long as you understand these key 2 points about tropical weather, you're going to have a good day in South Louisiana. So one of the questions I like to ask people is, if you were to label a single state as the hurricane state, which state would that be? And the majority of people say Florida. And guess what? It's not a trick question. It is Florida. Florida gets hit by more storms than any other state by far. But it's because it's got basically 3 coasts: an Atlantic coast, a west-facing Gulf Coast, and a south-facing Gulf Coast. So you've got 1,200 miles of coastline there saying, come on and hit me, Mother Nature. So of course it is the most active state in terms of landfalls. But when it comes to landfalls per mile of coastline, Louisiana actually gets hit 1.5 times more frequently per mile of coastline than Florida. In fact, Florida is number 4 on the list of landfalls per mile of coastline. North Carolina, number 1, Texas and Louisiana in a near dead heat at number 2, and then Florida, number 4. Here's a look at Atlantic basin activity over the last 100+ years. I only go back to 1900. To me, that's just a nice round cutoff period. Yeah, we could go back further, but the farther into history you go, the more problematic some of the data, especially tropical storms, become. So if you're looking at this figure here, by the way, the red bar indicates the number of hurricanes per season. The orange stacked on top is the number of tropical storms. So the height of the bar represents the total number of hurricanes and tropical storms by year. And most of you are probably already picking up on that pattern there. And many people want to label that as another sign of climate change. Well, one of the things we have to remember is that we've not been measuring and watching and analyzing these events with the same methodology going back even prior to 1940. Remember, in 1940, in the 1940s, aircraft reconnaissance began. And in fact, the initiation of aircraft reconnaissance was not a scientific endeavor, it was a military endeavor. It was to protect the Navy from sending ships into tropical systems out over the open water. So once the aircraft recon began, it became very evident very quickly, hey, this is a good tool for all of us. And so that has continued ever since. And by the way, it's still the Air Force Reserve that does our aircraft reconnaissance. So even though the data now are used mainly for scientific purposes and for monitoring purposes, it's still a military endeavor. But the real changing of the guard came in the 70s with satellite technology. Now we have the ability to watch storms 24/7, 365. In fact, we've gotten so good with satellite technology that there have been now at least 1 and maybe 2 years where the number of storms in a hurricane season increased in the following spring, because in watching the replay of the satellite video over time, the Hurricane Center specialist said, hey, there's one we missed. And they added it to the list after the season was over. So the point here is that while maybe we can't say it's totally apples and oranges from the first half of this time series to the second half, they're certainly not the same apples. They're Granny Smiths and Macintoshes. In fact, back here prior to aircraft reconnaissance, most experts will agree that these numbers back here are probably undercounted by an average of 2 storms per year. Because if a ship didn't sail into it or get near it, and it wasn't a storm that got near a coastline, it just didn't get counted. So yeah, we do have this uptick in activity here in the last 20 to 30 years, and some of that is legit, but at least part of that upward trend in the pattern is due to our changes in our observational practices. But yeah, you do have this hyperactive run of years that have been set up since 1995, and that relates to, on average, an Atlantic Ocean that has trended warmer than normal compared to the years prior to the mid-90s. So that uptick in activity makes sense. Warmer water would, at least in a sort of a very simple standpoint, encourage the potential for more storms to develop and for more storms to attain tropical or hurricane intensity. Now, here are just the storms for the Gulf of Mexico. And what I want you to notice here is you don't see that upward trend. And why is that? Well, we can think of the Gulf of Mexico as a billiard table. And almost every billiard ball is eventually going to hit a bumper. So no storms in the Gulf of Mexico can go uncounted. Somebody's going to see it. And so in the Gulf, we see that the pattern is fairly consistent. Yeah, there's that late mid-90s to current slight uptick in activity. Here's another period where we think we had a slight increase in activity in the Atlantic Basin. But you see, there's no real upward trend in the numbers there. By the way, on average, about 1 in 3 Atlantic storms end up becoming Gulf storms. Either they go from the Atlantic into the Gulf, or they actually start out in the Gulf of Mexico. So about 1/3 of the storms are storms that form in our very own backyard. And here's a look of, speaking our backyard, there's the Louisiana tropical activity since 1900. And you see, one of the things I like to point out with this slide here is there are very few spells of quiet runs of years. There's only 4 spells in this whole time series, one here, one here, one here, and just recently run here. Only 4 times where we go 4 years without some part of the state being impacted by a storm. That's pretty remarkable, and it's actually more frequent than most people expect. In fact, when we were in this 4-year spell here, I forecasted landfalls for the following year, which was 2017, simply because we'd never gone 5 years without a hit. So it just shows that, yeah, almost every year we have some activity. So here are the take-home numbers for tropical weather. There is better than a 50-50 chance of at least one, keep in mind now, of at least one named storm impacting Louisiana in any given year. And in fact, there's almost a 1 in 3 chance of a hurricane impacting some part of our state in any given year. And the other thing is that roughly 1 in 6 years, 2 or more times per decade, we get multiple hits. Of course, last year was off the charts with 5 landfalls by tropical systems. That's the record, most we've ever had. The prior record was 2002 with 4 landfalls. I'm going to skip over this slide here and just get to this one right here. One of the things I want to just touch on is forecasting tropical weather. A lot of people don't quite understand how it works. Forecasting where a tropical system is going to go requires this broad perspective. We basically have to figure out how the atmosphere is going to behave over that entire area to track or to anticipate where an Atlantic tropical system is going to go. And by the way, you don't only have to know what it's doing right now, but we have to know what's going to go on in that zone 5, 6, 7 days out, because you're trying to forecast where that storm is going to go. So as we put that storm in motion, you get the idea that it's all of these steering currents that create the path for that storm. The storms don't steer themselves. They're floating in the rivers of moving air in the atmosphere. Now, right now, the average error for a tropical storm in terms of where it ends up versus where it's forecasted, the 24-hour error is 40 miles. And for a lot of people, that seems unacceptable. But the fact of the matter is, when you look at this map and you realize what we're trying to forecast 2, 3, 4 days out, or even 24 hours out for that matter, 40 miles on this map is a pencil point. The forecasting skill really is remarkable. Unfortunately, 40 miles is also roughly the difference between a storm moving through Baton Rouge and a storm moving through Hammond. And for the public's perspective, that is a huge error. But from a meteorological perspective, that is a slam dunk forecast. And I'll leave it with that. And if there are any questions, I'll be happy to take them. Again, I appreciate your time. We're just coming up on 7:30 here, so I think I've done pretty well with the time. And let me know if you've got anything you'd like to ask, and I'll be happy to say I don't know.
Okay, Colette wants to know if you know Doug Tallamy.
Doug Tallamy.
Tallamy, yes, he went to the University of Delaware too, she says.
I don't think so. When was that? Remember, I was there during candles and snow. So yeah. Yeah.
Is rain bomb a fairly new term? Someone wants to know.
Rain bomb?
Yes.
Yeah. Look, we come up with these new terms because, unfortunately, the dark side of my profession, the media, loves them. So, and sometimes we even misuse the terms. Another big term of late is polar vortex. And suddenly look, the phrase polar vortex has been around for a zillion years, but someone has applied it to these big dips in the jet stream, and the public and the media gravitated and grabbed onto that. And so it's actually the media that has kind of redefined that term. So a rain bomb, or you'll even hear meteorologists will talk about a meteorological bomb, although typically that deals more with pressure than rainfall. But yeah, sometimes it's kind of trying to be cute with the language rather than actually expressing a real dynamic process.
Someone's not having much luck with the phone weather apps. So is there one that you think might be more accurate than the others?
You're kidding, right?
Well,
Well,
there's the WAFB one that's
You know,
pretty.
I have to, yeah, I was going to say, if I don't say my own, I'm going to be out of work in 30 minutes. So
you have WFB has its own weather app?
we do. We have our
Well,
own
see, I
weather
did
app.
not know that. So there
Yeah.
you go.
Well, then you're not watching us, are you?
Yeah.
Oh, well.
See, I caught you there.
I don't
because,
have TV. I don't have a.
then that's fine. Look,
Well, that's why you get the
yeah.
WAFB app on your phone, so
That's
you
right.
don't have TV.
And the one thing I will say about our app, I'll tell you, it is not perfect. None of them are. But most of the apps that you'll find are really driven by singular models. And the one thing with our app is that each of my team goes in and actually key enters the data for our app. So you'll see our app will say the same thing as our forecast. For some other weather apps from some other companies, their numbers don't necessarily jive. And again, most importantly here, when we do a forecast, typically I will look at 4, sometimes 5 different models before I formulate my human forecast. For most of those apps, they're being driven by a single model. And they're sophisticated models, but as I like to tell people, all models are wrong. Some are useful. And if you look at them all collectively, you probably will get a good idea of what's going to happen. But no model is accurate. It can be close. And so part of the human factor here is to go in there and try and ferret out the best parts of each of the models to formulate a forecast that we provide both on television and on our app.
How often are the reports updated when you're looking at? I mean, when you're getting hurricane information, is it all coming in on a? I mean, they have a scheduled time, like every 30 minutes or every.
I wish it was that frequently. It depends on what product you're talking about. Now, the National Hurricane Center typically issues their statements every 6 hours. When it gets closer to the coast, it goes from 6 hours to 3 hours. And then when it's knocking on the door, it can be even as frequent as once every hour. But typically it stops at about 3 hours, because by that point, the storm is so close to the coast that the local offices start to take charge. So it's really the domain of the National Hurricane Center when it's out over the open water. And they don't relinquish their authority. But once it starts really getting in your backyard, to be perfectly honest, I mean, at that point, I'm making my own decisions as much as listening to what the Hurricane Center has to say.
And how about when we get tornado warnings, tornado watches? Those seem to be popping up. I mean, again, at this time of year, you get a couple of them. Is that someone's reported a sighting? So just a regular schmo?
All right, two different things here, a watch versus a warning. A watch means that conditions are favorable. The way I like to describe it to people is a watch is when you get up on Sunday morning and you see eggs out on the counter. Looks like somebody's going to get breakfast.
Okay.
A warning is when the plate is in front of you. It's time to eat.
Okay.
So the watch is the conditions are favorable. the warning means something is happening. And the warning can come from multiple sources. It can either be something has been cited, or more frequently, most of our warnings are radar determined. In other words, the radar system, which is so sophisticated, it can pick out circulation in a thunderstorm. The radar system says, we think we've got circulation here that's significant enough to merit a tornado warning. Now, a thunderstorm warning means that, okay, we've still got a powerful thunderstorm, but we're not seeing circulation. But both of those are either observed by a ground report, or more often than not, assessed by inspection of the radar signal.
Well, I want you to know I downloaded the app while you were talking.
Well, there you go. You know how easy it is.
Well, now you can.
Yeah, it's got some pretty cool stuff on here. It's got hourly, daily, radar, and even traffic.
Yep.
Well, Jay, you can tell him you missed work this evening and you signed up a customer, so it was worth it.
Oh, I'm going to use that.
Yeah. Good deal. There are a couple more. Alice Miller wanted to know, is 2021 summer a calmer one for us?
Alice, all I can tell you is I hope so. And I'm assuming you're talking about tropical weather. I mean, could we have a repeat of last year? Extremely unlikely. But I think what we are going to see, one of the things that's also, I didn't mention this in talking about tropical systems, the satellite really has changed. The use of satellites for tropic tracking systems really has changed everything. One of the things we see, sort of an ancillary aspect of tropical systems now, is that we're actually seeing, we're identifying more storms that are short-term storms, 2 and 3 day storms that spin up and fizzle out, that probably weren't being captured, caught, analyzed as little as 20 years ago and 30 years ago. So what we have to be really careful of sometimes, again, with this increase in activity on that graphic, is understanding that the rules have changed. So especially the National Hurricane Center is being far more aggressive now in identifying storms than it was even 15 or 20 years ago. So the numbers are going to be up simply because of the change in the approach to analyzing storms, particularly storms out over the open water. Right now, we are thinking that this could be a relatively active season. Most of the forecast groups are still churning away at those numbers. We'll start to see the earliest forecasts pop out next month. But there's a couple of reasons I anticipate another above average year. Number one is something that's called persistence, and it makes sense. I mean, we've just had a string of active years. Something's up and Mother Nature is angry at us and she's just creating these storms. So that's persistence. Now, one could argue persistence is not a scientific tool, and it is not. It's correct. It's purely statistical. So, a purist would throw persistence out. Hey, look, I just let the numbers speak for themselves. Number two is that we are still looking at a relatively warm Atlantic Ocean. Okay, so slightly warm, and we're not talking about the water being 5-10 degrees warmer than normal. Just a degree or two under the right circumstances can be enough to make the difference between whether a tropical wave becomes a tropical storm or not. I mean, it really is that tenuous as to whether it's going to happen. And then the third point, one thing that we talked about during this presentation, but I didn't talk about it from a tropical perspective, El Niños tend to inhibit or reduce Atlantic tropical activity. La Niñas tend to allow greater numbers of tropical storms and hurricanes to form. We're in a La Niña right now. We know we're going to transition to El Niño. The question is, will that transition occur before we get to the height of the hurricane season? And right now, it's kind of iffy, so as to whether we're going to make that transition between now and say August. If we don't, then we'll have another factor there, the La Nina or La Nina/neutral conditions with ENSO that tend to be associated with a slightly higher number of storms. All that said, it tells us nothing about the threat to Louisiana. In fact, I just, on TV, I'll throw out those forecast numbers that the experts come out with, the prognosticators. So what if they say 14 named storms next season or 18 named storms? As I get older, I don't care about 18. I care about how many are coming here. And we never in my lifetime are we going to have that kind of skill to anticipate even activity in the Gulf of Mexico, much less how many of those are coming to Louisiana. Now, the Gulf was very active. By the way, remember we said that 1 in 3 rule? Well, it applied last year. 30 named storms, 10 of them were in the Gulf. But there's no reason that 5 of those 10 should have come to Louisiana. That was just bad luck. There's nothing about it that was scientifically explainable. It's just bad luck.
So is there consideration for starting the hurricane season earlier? Stacy wanted to know.
Good question. And actually that floated about because someone had, and actually what happened, the World Meteorological Organization, the WMO, which is kind of the United Nations weather experts, and the National Hurricane Center agreed to start issuing tropical weather outlooks 2 weeks earlier. Normally, they don't start issuing those outlooks until June 1, the first day of hurricane season. Because we've had a run of years, something like 6 of the last 7, we've had a named storm before June 1. The Hurricane Center has agreed to start issuing those tropical weather outlooks, which come out twice a day. They agreed to start issuing them in mid-May, which is, by the way, that's when they issue them for the Eastern Pacific. So it's not a big change in their process, but a lot of people took that to signal that they're about ready to expand the hurricane season. Right now, that's not, I will say it's been lightly discussed, but it's not on the table. The bottom line is, does it really matter? I mean, June 1 to November 30 are purely artificial anyway. Would there have been tropical systems in every month of the year? What we did, or what the specialists did, was they said, we're just going to draw a calendar date that fits a good window of season. I mean, certainly the fact that it was June 1, the first day of June and the last day of November is something very close to arbitrary.
So we could all take a Sharpie marker and just make it a little longer if we needed to.
Well, the fact of the matter is, I mean, are you going to say, oh, that's not supposed to happen because it's May 22nd? I mean, and in fact, the last several years have told us, stop thinking that way. You need to be ready for hurricane season before the 1st of June. And by the way, Louisiana has been hit by one tropical system in May. So we are not as out of the woods until June 1st or July 1st. We need to be ready before the season begins.
So get your hurricane prepared kit. Just be ready.
Just do it, yeah. And for most of us, it's simply a matter of spending 5 minutes at the kitchen table and reminding ourselves, what do we need to do? What do we need to do? One of the things you got to decide is, are you a person that might need to consider evacuation? Truth of the matter is, I never intend to evacuate from Baton Rouge. But if I had family members that were absolutely dependent upon access to electricity, I might rethink that because, power goes out readily around here. And with a tropical system, the power, we saw it in Gustav. There were places in the Baton Rouge area that were without power for better than 3 weeks.
That was me. I was out of power for 3 weeks when that happened.
So can you imagine if you had an elderly family member who was absolutely dependent on access to electricity? So those are the things you have to think about. Evaluate uh, what you can, I even tell people with a lot of little kids in their family, you might want to think about getting out of town, because you go a week without power with, a handful of youngsters with nothing to do. You're talking about going crazy yourself. I mean, yeah, look, staying in a hotel or staying at Aunt Martha's can be expensive. But on the other hand, there's also a sort of an aspect of a mental health from the adult's standpoint that has to be considered.
Jay, we have one of our participants that has lived here 14 years, and she seems to notice a trend that the temperatures are staying in the 80s more often in May. And she said usually by mid-April they were in the 90s, and she wanted to know, is there a reason for this?
Well, we showed earlier that things have gotten a little bit warmer, but part of that is, and this actually, I mean, we could go into the whole urbanization discussion. I could spend an hour talking about that. And it's not just about urbanization, heat island effect, and temperatures. It's also about the flood potential. So warmer in May, yeah, we've had a string of warm mid-late springs that have gone right into summer. So you can almost think of it as summer just starting early. Our summer temperatures haven't been that much above normal, but there's kind of without getting into the physics, there's kind of a limitation to how hot it can get here on most days because it's so humid. The humidity actually keeps the temperature from rising where it would if the air was dry. So that's a good thing in that one sense. But yes, it has been warmer, and we're seeing that across the South, warmer springs, and in fact, warmer winters. And I'm not removing the climate change. I don't like the phrase global warming, but there's certainly a climate change and a human factor there. And some of that human factor has to do with how we're changing the landscape. And all you have to do is EBR is a great example of what development can do. Development is a reflection of success. But in our area, every time you build a new neighborhood, that's more water that has no place to go. And so you have people who are saying, well, I'm seeing the water come up higher and higher than it ever did before. Well, even if the rainfall was the same year in, year out, you would be seeing that effect because the retention space in our local environment is going down, down, down because people don't want water sitting in their backyard. So they get it out to the curb faster, which gets into the co-meet and the A-meet faster, which makes it rise in other places faster. But again, back to the real question, warmer springs seem to be a recent pattern, yes.
Well, just so you know, when you said you could talk an hour on it, people were popping up saying, schedule a second presentation. That's what I was thinking. So apparently they want to hear you talk for that extra hour. I also wanted to read you word for word what Alice said. She said, you definitely are the weather person in our house. My husband would not move any plants or wrap the pipes until you issue the order. Thank you so much for watching out for us. Enjoy your presentation very much. You've gotten kudos all up and down about how awesome your presentation is this evening.
Well, that's very, very kind. And, I've been lucky professionally, both at LSU and in television. I am blessed to be surrounded by weather people that you tell them this, but all three of them are smarter than me. So
this is being recorded. So
and it has made things very, very, very easy for me for a guy who still 25 years later is not comfortable with the camera. So I've been very lucky, and I appreciate the compliment there. And I will say this, and I don't think any of my people are listening now. So whether you follow our station or one of the other stations, one of the things that has changed in my business is that all these young kids that are doing TV weather now, and I am grandpa, but almost all of them now have weather degrees, weather science degrees, whether it's meteorology or atmospheric physics. So they are weather scientists on TV, which is a change from the old days where the weather guy was the one who couldn't get the anchor's chair. So what I think you're going to find is that more often than not, the basic forecast across the media outlets is generally the same. The one thing that and again, I'm extraordinarily biased by this, but the one thing I would claim is that we probably, my team probably has more collective experience doing this than any of our competitors, and that's again is a blessing for me, because I can do like I've done today. I had no problem letting Jared cover for me while a cold front is rolling through the area, because I knew that, quite honestly, he does a better job explaining it to people than probably I would. So thank you again for the very kind compliments.
Yeah. Well, we hope to schedule you again. We'll come up with another, or you come up with another topic that would be great for Master Naturalists to address, whether it is the urbanization, or we're all about that. So anything.
Well, it's a big one, and it's a huge one with respect to the flood concerns that we're having. And when I started putting this talk together, I thought, wait a minute, these guys are naturalists. They want to hear more about the impact on the natural environment. But you know what? It's getting harder and harder to find a natural environment locally. Everything has a human signature on it. Definitely. And it's that signature that is changing things. And what we could talk about down the road, I actually took it out of this slideshow because I knew it was going to get too long, but a lot of the LSU environmental oriented people aren't big fans of mine, because I am not ready to say everything is, the changes are all human. And I'm not ready to say, look, I'm not ready to go back to stone knives and bear skins just to minimize the human impact on the environment. I don't think there's any way we can do that. There's no reversing it. And so I'm at a place where we need to be thinking more about mitigation strategies rather than encumbering ourselves with limitations that are going to be in some ways overwhelming. Mm-hmm. But yeah, I'd be happy to talk again. We can meet offline and chat about maybe an idea or two. And I hope that it sounds like you all got a little something out of it. I had a great time, so I'll be happy to do it again.
Well, that's.
Yeah, when he started talking about urbanization, Natalie put in the comments, preach, preach.
Look, we have to be ready to accept that. Like I said this before, growth is the result of progress, and nobody wants to put the cap on progress. So the growth needs to be done with the right kind of constraints and the right perspective. And yeah, we could touch on that down the road too.
Sure, that's great. Well, Denise just said we need more trees. So that would be some mitigation things, is definitely putting more trees out there.
And it would be about planning where to put them and how to put them, and maybe stopping with the clear-cut approach of new neighborhoods.
Right. And before the development is even clear-cutted, like you just said, they already have plans for not just the houses and the lots where they're pouring concrete, but where the tree's going to go.
Right. Right.
Yeah.
Right.
And the types of trees too.
Well, that's what needs to be done. Now, the problem is that you're not going to get a builder to agree to that unless you legislate it.
Right.
And so it has to be a top-down solution, because that's going to cost him money. Mm-hmm. Every time we tell a builder, okay, now you've got to put in a detention pond. Well, there goes four homes, the space for 4 homes. So there's obviously going to be resistance there. I get it. And I don't blame them. That doesn't make them bad guys. We just need to make it so that it's not a discussion point anymore. You will do this.
Yeah, yeah, true. Well, we will have you back, like you
Okay,
said.
sounds good.
And Jay, thank you so much. You're on tonight. We can watch you again tonight if we miss you after
10 o'clock, yep.
10 o'clock. Okay, so you'll give us the update of this cool front coming in and
Yeah. And so the big question now is just how cool. I've already had a number of people asking me, do they have to prepare for a frost?
Oh, oh no.
Now we're heading to the 30s.
Oh, okay.
So the question is, are we going to get down to the mid 30s? And I'm not going to answer that. You'll have to watch.
We'll watch it. We'll watch it.
All right.
So much, Jay. We really appreciate it. We'll
All right. Everybody take care. Thank you so much.
Bye-bye.
Bye.